Let Gn be a sequence of integrable functions which converges almost everywhere on an integrable function g. Let f of n be a sequence of an integral function such that f of n modulus f of n is less than equal to g of n, and the sequence f of n converges to f if integral of g is equal to limit of integral g of n, then integral of f is equal to limit of integral f of n. Now since we know that now proof of this question is, since we know that f is a measurable function over a set of E and there is an integrable function g such that modulus of f is less than g, then f is a integrable function over E. So clearly each f of n is integrable over E. Also limit f of n is equal to f almost everywhere on E, and modulus of f of n is less than equal to of g of n almost everywhere on E, which implies modulus of f is less than equal to g of n almost everywhere on E. Hence f is integrable over E. Let phi n be a sequence of functions defined by phi n is equal to f of n plus g of n. Clearly phi n is a non-negative and integrable function for all values of n. Therefore by Fato's lemma we have integral e to base bracket starts f comma g is equal to less than equal to limit n tends to infinity integral e to base small bracket starts f of n plus g of n bracket close, which implies integral e to base f plus integral e to base g is less than equal to limit lower limit n tends to infinity integral e to base f of n plus lower limit integral g of n. Now common term again integral which implies integral e to base f of s limit integral g of n less than equal to limit lower n tends to infinity integral e to base f of n plus limit f of n. Now this is g of n. Now g of n and g of n both sides cancelling common terms, we getting this and this terms which implies integral of e to base f is less than equal to limit of e lower limit a integral n tends to infinity integral e to base f of n. Similarly we get psi of n be a sequence of functions defined by psi is equal to gn minus f of n. Clearly psi n is non-negative integral function for n. So again by Fato's lemma we have integral e to base bracket starts g minus f bracket close is less than equal to limit n tends to infinity integral e g of n minus f of n, which implies integral e g minus integral e to base f less than equal to limit lower n tends to infinity integral e to base g of n minus limit lower n tends to infinity integral e to base f of n, which implies limit g of integral e to base g of n minus integral e to base f of n less than equal to limit g of n minus limit lower f of n. Now limit g of n cancelling out, which implies minus f of integral e to base f of n less than equal to limit of lower n tends to infinity integral f of n, which gives out to be integral e to base f of greater than equal to limit upper of integral e to base f of n, which is equation 2. From 1 and 2 we get integral e is equal to f is equal to limit lower integral e to base f of n is equal to limit upper e to base f of n, but the limit lower integral e to base f of n is equal to limit upper integral e to base f of n. So limit integral e to base f of n, hence integral e to base f is equal to limit integral e to base f of n, which is the result.